At LASER World of PHOTONICS this year, we have seen an evolution on the wavelength range of many optical instrumentations, and those require optics that go from the visible all the way to the low-wave infrared. When it comes to testing, it always requires different pieces of equipment for each wavelength range for the wavefront sensors. But today, I'm at PHASICS, at the PHASICS booth, and they showed me something that could revolutionize the way that we test optics. What did you bring?
So what we brought today is a testing system, so a wavefront measurement system that is able to perform double pass measurement. Here we have, for example, photographic objective that we test in double pass. So we create here a point source that is collimated, that is reflected on a flat reference mirror that goes back, and that is being analyzed by our high resolution wavefront sensor called SID4HR. So here today we brought a visible wavelengths measurement system. This system is completely modular. It's called Kaleo Kit. The full system is called Kaleo Kit, and that allows to change the modules to fit the different requirements. That means different F numbers, different wavelengths, so that we can cover any requirements between UV and long wave infrared.
What we are seeing here is the resulting beam shape.
So here, typically on the screen, what we see is the MTF that you can show in different formats. We can recognize here the typical shape of the MTF response to different frequency that we input. On the top right, we see here a phase map which corresponds to the current quality that we can measure from this objective in a one-shot measurement.
One thing that is very important to notice, this is a fully modular design, and all you need to do is to replace this module. You can see that this module is from 400 to 1.1 micrometers. You could actually replace this with this module with any other modules. Which other wavelength range do you provide?
Indeed, so at PHASICS we have the largest and the broadest range of wavefront sensors, so that we can cover wavelengths from 190 nanometers, so deep UV, to long wave infrared to 14 microns in a continuous way. So here we could put, for example, any wavefront sensor that we have. So, for example, SID4 DWIR, which is on the market, the wavefront sensor that covers the largest range from 3 microns to 14 microns alone.
The best part of LASER Munich is that the companies really make a big effort to demonstrate their technology live, and I love that. That was great. That was really good.